The truth about your F-150's silent killers, your late model Ford F-150, is rolling off the assembly line pre-programmed to slowly destroy its own engine and drivetrain. The very features Ford markets as intelligent, eco-friendly, or smart are actually shortening your vehicle's lifespan by half, keeping dealership service bays packed with profitable, out-of-warranty rebuilds. Most owners have absolutely no idea that the factory settings they trust every single day are actively grinding their engine bearings to dust, starving critical components of lubrication, and cooking expensive transmissions. Today, I am exposing 5 factory settings and features that are quietly ruining your truck without you ever realizing it. Setting number 3 has caused more timing chain stretch, guide wear, and phaser failures in my shop than almost any mechanical defect. And setting number 1 is so deceptive that owners actually think it is protecting their transmission when it is doing the exact opposite. If you want your truck to survive past 100,000 miles without a 5-figure repair bill, you need to understand the mechanical reality behind the marketing. Let's get into it. Setting 5. The Intelligent Oil Life Monitor and the 10,000-mile oil change interval. The common behavior: you drive your truck daily, watching the oil life remaining percentage on your dashboard slowly tick down. You trust the computer when it tells you that you still have 30% life left at 7,500 miles, so you happily wait until the dashboard display finally warns you at 10,000 miles or 1 full year before taking it in for a service. The marketing versus reality. What Ford says: the Intelligent Oil Life Monitor, IOLM, uses an advanced software algorithm that analyzes engine operating temperatures, towing habits, idle time, and driving patterns to calculate precisely when the oil is depleted, safely extending oil change intervals up to 10,000 miles to reduce your cost of ownership and environmental impact. The hidden mechanical reality. The 10,000-mile interval is a marketing metric designed strictly to win the lowest cost of ownership battles in fleet sales brochures. The algorithm does not have a chemical sensor in the oil pan. It cannot see what is actually happening to the physical chemistry of your lubricant. On both the 2.7-liter and 3.5-liter EcoBoost engines, direct injection sprays fuel at up to 2,900 psi directly into the combustion chambers. Under high boost and cold start conditions, a highly measurable percentage of raw gasoline washes past the piston rings and enters the oil crankcase. This is called fuel dilution. I have pulled oil samples from EcoBoost trucks at 7,500 miles and found fuel dilution levels exceeding 4.5%. Raw fuel is a solvent, not a lubricant. It violently strips the viscosity of a standard 5W30 oil down to a 0W16 or lower, shearing the protective oil film thickness down below 1.5 microns. Additionally, direct injection produces highly abrasive microsoot. When this soot suspends in fuel-diluted, thinned-out oil, it acts like liquid sandpaper. The catastrophic consequence: the thin, fuel-diluted oil is forced into the variable camshaft timing, VCT, phasers, and the turbocharger journal bearings. The turbochargers spin it up to 150,000 RPM on a microscopic cushion of oil. When that oil film shears due to fuel dilution, you get direct metal-on-metal contact. On the 5.0-liter Coyote, the hydraulic tensioners and VCT phasers rely on precise oil pressure to hold their positions. Thin oil bleeds out of the phaser assemblies during hot idle, causing the internal locking pins to violently slam against their housings. This is the root cause of the infamous Ford cold start cam phaser rattle. By the time the dashboard tells you it is time for an oil change at 10,000 miles, your timing chains have already stretched, your phaser pins are ovaled out, and your turbo bearings are worn beyond recovery. It is a cumulative, invisible wear pattern that culminates in a $4,500 timing job right around the 110,000-mile mark, conveniently right after your factory powertrain warranty expires. The real solution: change your oil and filter every 5,000 miles max, or every 3,000 miles if you regularly tow or idle frequently. Always use a high-quality full synthetic oil and an OEM Motorcraft filter with a silicone anti-drainback valve. Treat the dashboard's oil life monitor as a countdown to engine damage, not a helpful reminder. Setting 4. The default on auto start-stop system. The common behavior: every single time you turn the key, or press the start button. Your truck automatically enables the auto start-stop feature. You pull up to a traffic light, stop sign, or gridlocked highway traffic, and the engine instantly cuts out. The cabin goes quiet, the RPM needle drops to 0, and the second you release the brake pedal, the starter fires the engine back up, and you drive off. The marketing versus reality. What Ford says: auto start-stop maximizes your fuel efficiency and drastically reduces tailpipe emissions during idling by seamlessly shutting down the engine when the vehicle comes to a complete stop, automatically restarting it the millisecond you need to move. The hidden mechanical reality. This feature was engineered to satisfy federal CAP corporate average fuel economy standards, allowing Ford to claim fractional fuel economy gains across their fleet. But the mechanical price your engine pays for those fractions of a mile per gallon is staggering. To understand why this is highly destructive, you must understand the difference between hydrodynamic lubrication and boundary lubrication. Hydrodynamic lubrication, engine running. When your engine is running, the oil pump forces pressurized oil into the clearances between the crankshaft journals and the main bearings. This pressurized flow creates a hydraulic wedge that physically lifts the heavy steel crankshaft off the soft bearing shells. There is zero physical contact between the spinning shaft and the bearing. The crankshaft literally floats on oil. Burial lubrication. Engine stopped. When the engine shuts off, oil pressure drops to absolute zero. The heavy crankshaft sinks through the hot, microscopic oil film and rests directly on the aluminum tin alloy bearing face. When the auto start-stop system restarts the engine, those metals rub directly against each other for a critical fraction of a second before the mechanical oil pump can spin up, build pressure, and re-establish that protective oil wedge. The catastrophic consequences standard. Non-start-stop vehicle will experience roughly 50,000 start-stop cycles over its entire operational lifetime. An F-150, utilizing the default factory auto start-stop system, will experience over 500,000 start-stop cycles in the exact same lifespan. You are subjecting your main bearings to 10 times the wear. I have personally torn down engines run with constant start-stop usage and inspected the crankshaft rod and main bearings. The protective Babbitt overlay is completely scrubbed away, exposing the copper backing. Furthermore, this system is brutal on your turbochargers. If you have been driving your EcoBoost hard on the highway under heavy boost, your turbochargers are glowing hot, reaching temperatures over 900 Fahrenheit. If you abruptly pull off the highway and stop at a red light at the end of the exit ramp, the engine immediately shuts off. This instantly kills the oil flow to the turbochargers. The stagnant oil trapped inside the scorching hot turbo bearing cartridges literally cooks, a process known as oil coking. The oil bakes into hard carbon deposits that permanently restrict the microscopic oil feed lines, starving the turbos for protection the next time you accelerate. The real solution: make disabling this system your very first muscle memory action when you sit in the cabin. Press the auto start-stop delete button on the dashboard every single time you start the truck. Alternatively, you can use an OBD2 adapter and a software tool like ForScan to permanently disable the start-stop feature in the vehicle's body control module, BCM, or install an aftermarket plug-and-play start-stop eliminator that remembers your preference. Your crankshaft bearings and turbochargers will thank you. We've already looked at how Ford's inflated oil life targets and constant engine cycling chew through your bearings and bake your turbos. Now, we are moving into the heart of the drivetrain, where factory programming actively sacrifices your physical hardware to chase shifting comfort and artificial EPA numbers. Setting 3. The skip-shift programming in the select-shift 10-speed transmission. The common behavior: you pull away from a stoplight under light or moderate acceleration. Instead of a smooth, linear progression through the gears, you watch the gear indicator on your instrument cluster jump directly from first to third, and then from third to fifth, completely bypassing second and fourth gear. The truck feels like it is bogging down slightly, but it keeps moving, and you assume the computer knows the most efficient way to get you up to speed. The marketing versus reality. What Ford says: the select-shift 10-speed transmission features progressive range selection and adaptive skip-shift logic. By skipping unnecessary gears during light load acceleration, the transmission reduces shift frequency, optimizes engine RPM for maximum fuel economy, and provides a smoother, quieter driving experience, the hidden mechanical reality. Skip shifting is not about your comfort. It is a desperate calibration trick designed to squeak past city fuel economy testing by keeping the engine RPM as low as physically possible, even if it forces the engine to lug. When your transmission skips from first to third gear, it forces the engine's RPM to drop drastically. To maintain your rate of acceleration at this artificially low RPM, the engine must produce significantly more torque on the 2.7-liter and 3.5-liter EcoBoost engines. The engine control module responds by demanding immediate boost from the turbochargers. This creates a massive spike in cylinder pressure at a very low engine speed, typically around 1,200 to 1,500 RPM. Mechanically, this is called lugging the engine. At low RPMs, your engine oil pump is spinning slower and producing less volume and pressure. You are pairing maximum mechanical load and extreme cylinder pressures with minimum oil flow. The catastrophic consequence: this low RPM, high load condition places an immense physical load on the piston skirts, connecting rods, and crankshaft main bearings. The piston assembly literally rocks back and forth inside the cylinder bore, scrubbing the piston skirts and scoring the cylinder walls. Furthermore, the skip-shift process itself is brutal on the transmission's internal clutches. To skip a gear smoothly, the transmission must slide and slip the incoming clutch packs to match the drastic RPM drop. This controlled slipping generates intense localized heat, which glazes the clutch friction material and degrades the transmission fluid. The constant back-and-forth hunt between odd-numbered gears creates a physical clunking and erratic shifting behavior that eventually wears out the main valve body. In my op, I regularly see CDF clutch drum failures on these 10R80 transmissions. The internal bushing inside the CDF drum physically slides out of place because of the constant, uneven thermal expansion caused by the excessive slipping and heat generated during skip shifts. Once that bushing moves, it blocks the oil passages, starving the clutch packs of hydraulic pressure, leading to slipping, harsh shifts, and eventually a total transmission failure that costs upwards of $7,500 to rebuild. The real solution: take control of your transmission's shift logic by putting the truck into Tau hot haul or sport mode every time you drive. Both of these modes recalibrate the shift strategy to disable skip shifting entirely, forcing the transmission to utilize all 10 gears sequentially. This keeps the engine in its optimal RPM band where oil pressure is high, cylinder pressures are balanced, and the transmission clutch packs engage cleanly without excessive slipping. If you want a permanent fix without pushing buttons every trip, a custom transmission calibration tune from a reputable tuner can permanently disable skip shift in normal mode. Setting 2. The ultra-low viscosity 75W85 rear differential fluid and the 150,000-mile service interval. The common behavior: you drive your truck for years, towing trailers, hauling loads in the bed, and tackling winter weather without ever thinking about your rear axle. You check the owner's manual, see that Ford recommends changing the rear differential fluid at an astonishing 150,000 miles, and assume the synthetic fluid inside is a lifetime lubricant that requires zero attention from you. The marketing versus reality: what Ford says. The factory-fill synthetic rear axle lubricant is engineered to provide superior high-temperature stability and wear protection under extreme loads, allowing for a maintenance-free interval of 150,000 miles under normal driving conditions, while reducing parasitic drag to improve fuel efficiency. The hidden mechanical reality: Ford filled your rear differential with incredibly thin 75W85 gear oil, and in some newer models, even thinner fluids, to minimize fluid drag and eke out a fraction of a % improvement in fuel economy, while thin oil reduces drag. It also drastically reduces the physical thickness of the oil film between the ring and pinion gear teeth. When you tow a trailer or carry a heavy load, the extreme pressure between the meshing gear teeth generates immense localized heat. The oil film is sheared down to a microscopic level. Additionally, differentials do not have oil filters. As the gears wear in during the first few thousand miles, Microscopic metal shaving particles shear off the gear teeth and bearings. This metallic debris suspends in the thin fluid, turning your gear oil into a highly abrasive lapping compound that circulates continuously through the pinion and carrier bearings. The catastrophic consequence by leaving this thin, metallic-laden fluid in your rear axle for 150,000 miles. You are allowing that abrasive slurry to slowly erode the hardened face of the pinion and carrier bearings. The first symptom is a faint, high-pitched howl or whine coming from the rear of the truck when you are cruising on the highway. This whine is the sound of your ring and pinion gears wearing an abnormal pattern into each other because the bearings have worn down, allowing the gears to physically deflect and lose their precise alignment. Once the gears develop this wear pattern, they cannot be adjusted back to quiet operation. You are forced to replace the entire ring and pinion gear set, along with all the bearings and seals. I have opened up rear differentials at 80,000 miles that have never had their fluid changed, and the oil is pitch black, smells scorched, and is absolutely saturated with silver metallic paste. The magnet on the fill plug is typically caked in metal shavings. The bearings are pitted, and the gear teeth are visibly scored. Waiting until 150,000 miles to service this axle is a guaranteed recipe for a complete rear differential rebuild costing between $800 and $2,500. The real solution: dump the factory rear differential fluid early and upgrade the viscosity. Perform your first differential service between 5,000 and 10,000 miles to flush out all the initial wear metal from the factory break-in process. Moving forward, service the rear differential every 50,000 miles. When you refill it, step up from the factory recommended thin 75W85 to a high-quality full synthetic 75W140 gear oil, especially if you have the 9.75-inch axle and do any regular towing. The slightly thicker fluid provides a vastly superior cushion of protection under load and high operating temperatures, ensuring your gears and bearings run quiet and last the lifetime of the truck. We've exposed how Ford skip-shift programming beats up your clutch packs and how ultra-thin differential fluid turns your rear axle into a self-destructive grinding machine. But the single most deceptive, hidden threat to your truck's drivetrain is a temperature-regulating component that sits right under your nose, quietly cooking your expensive transmission while your dashboard gauge lies directly to your face. Setting 1. The high-temperature transmission thermal bypass valve, TBV, and the deceptive warm-up loop. The common behavior: you monitor your dashboard's digital gauges while driving or towing, noting that the transmission fluid temperature consistently hovers right around 210 Fahrenheit to 215 Fahrenheit, sometimes creeping up to 225 Fahrenheit under load. The gauge on your cluster stays safely in the normal blue to white zone. You assume everything is perfectly fine because the dashboard is telling you so, and you continue to tow or commute without a second thought. The marketing versus reality. What Ford says: the integrated transmission thermal bypass system is engineered to quickly warm up the 10-speed transmission fluid to its optimal operating temperature range. By maintaining a higher, more consistent operating temperature of around 200 Fahrenheit to 215 Fahrenheit, fluid viscosity is reduced, parasitic drag inside the transmission is eliminated, and the truck achieves maximum highway fuel efficiency. Reddit: the hidden mechanical reality. Once again, physical durability has been sacrificed on the altar of EPA testing to squeeze out every possible tenth of a mile per gallon. Ford's engineering team deliberately targeted an incredibly hot transmission operating temperature. The mechanism responsible for this is the thermal bypass valve, TBV, located on the transmission cooling lines. Unlike older heavy-duty trucks where transmission fluid flows constantly through an external cooler, the 10R80 transmission runs on a closed warm-up loop. Thoroughbred diesel factory TBV acts as a gatekeeper. It is physically blocked, completely preventing fluid from traveling to the external transmission cooler until the internal fluid temperature reaches a staggering 190 Fahrenheit to 195 Fahrenheit. Only then does the internal wax pellet or spring expand, allowing the valve to open and redirect hot fluid to the auxiliary radiator. But here is what Ford doesn't tell you: heat is the absolute. uncontested #1 killer of automatic transmissions. At 190 Fahrenheit, automatic transmission fluid begins its gradual breakdown. For every 20-degree increase above 220 Fahrenheit, the functional life of your transmission fluid is cut exactly in half by keeping the fluid locked in a tight warm-up loop and refusing to send it to the cooler until it is already scorching hot. Ford is baking the fluid from day one. Worse yet, these mechanical bypass valves are notorious for sticking. The internal copper and wax actuator can degrade or jam, causing the valve to stick completely closed. When this happens, fluid is permanently blocked from reaching the external cooler. Your transmission temperatures will rapidly skyrocket past 240 Fahrenheit, 250 Fahrenheit, and higher. Ready Tisha 1 and the absolute kicker? The factory temperature gauge on your dashboard is heavily damped by software. It is a dummy gauge. It will stay squarely in the normal range, even as your fluid is turning to liquid coal. And it won't trigger a warning light until your transmission is already actively melting itself from the inside out. The catastrophic consequence when transmission fluid is consistently baked at 215 Fahrenheit to 225 Fahrenheit, it undergoes thermal oxidation. The fluid loses its engineered friction characteristics, turning from red to a dark, burnt brown. Without those friction modifiers, the transmission clutches begin to slip during shifts, generating even more localized heat. The internal rubber seals, pistons, and O-rings bake until they are hard, brittle plastic, losing their ability to seal hydraulic pressure. Once pressure drops, the clutch packs glaze and burn, the solenoids jam with oxidized varnish, and the infamous 10R80 CDF clutch drum bushing completely migrates out of its housing, rendering your truck undrivable by forcing the transmission to run on the ragged edge of overheating just to save a drop of fuel. Ford is practically guaranteeing that your transmission will suffer a catastrophic slip, flare, or total hard part failure long before it should. The real solution: lower your transmission's operating limit by replacing the restrictive factory bypass valve with a full flow or low temperature thermal bypass valve. High quality, direct fit aftermarket options, like the Mishimoto full flow thermal bypass valve, replace the cheap factory housing with a CNC machined billet aluminum unit. This modification allows fluid to pump through the external cooler as soon as the truck is started, or drops the opening temperature down to a much safer 160 Fahrenheit. Vivid Racing: with this simple swap, your normal operating transmission fluid temperatures will instantly drop by 30 to 40 degrees, staying safely in the 170 Fahrenheit to 180 Fahrenheit range, where fluid does not break down and clutch packs can survive indefinitely. Conclusion: take back control of your truck. At the end of the day, your F-150 is a highly capable, exceptionally engineered piece of machinery. The mechanical bones of the Coyote V8 and the EcoBoost V6s are incredibly strong, but they are being suffocated, starved, and cooked by factory programming and service intervals that serve the manufacturer's corporate interest, not your wallet. Let's summarize the game plan to save your truck. Dump the 10,000-mile oil target. Change your oil and filter every 5,000 miles to flush out fuel dilution and abrasive microsoot before it kills your cam phasers. Turn off auto start-stop. Kill this feature every time you start the truck to protect your crankshaft bearings from metal-on-metal wear and stop hot oil from coking inside your turbos. Stop the skip shift. Use tow haul or sport mode to force the 10-speed transmission to run sequentially, saving your engine from low RPM lugging and protecting your clutch packs. Flotch your rear differential early. Service the rear axle at 10,000 miles to remove break-in metal, and step up to a durable 75W140 full synthetic gear oil. Fix the transmission warm-up loop. Install a low-temp or full-flow thermal bypass valve to drop your transmission temperatures back down to a safe, reliable operating range. Vivid Racing: the manufacturer's job is to sell you a truck and make sure it survives just long enough to clear the warranty period. Your job is to make it last. By taking these 5 simple, actionable steps, you are overriding the corporate compromises and protecting your investment for the long haul. If you want more of these direct, real-world teardowns and technical breakdowns that actually save you thousands of dollars, make sure to hit that subscribe button. Drop a comment below and let me know how many of these factory settings you're still running or which system you want me to dissect next. Keep your fluids clean. Keep